Rhea, can you believe that Professor John gave me a medal for getting A's in all the tests? Ugh. What's the matter, Rhea? Nothing. Well, the thing is that all my cousins who go to a school a mile farther from here come to home with fancy and colorful tables, while Professor John tells us to make black and white tables. Not everyone gets full marks and is unaffected by this, Shimra. How will I earn marks in my great university if I make these dull series? Do you actually know that tables are just for organization of data and not for the presentation of data? Presentation of data is all about catching the attention of the reader. Let's go to my close friend Mahira to learn all about it. Shimra! And I'm afraid I do not know who you are. No need to be afraid. This is Rhea. We both wanted to dig deep into statistics and learn about the presentation of data. Well then, what are we waiting for? Let's learn the presentation of data along with my dear friends. So, presentation of data is the illustration of data in an attractive and concise manner. There are three kinds of presentation of data: textual presentation, tabular presentation, and diagrammatic presentation of data. Now, textual presentation, as the name suggests, is data represented in the form of text. So, this type of presentation is often suited for small amounts of data, as too much reading can cause boredom and confusion. Some examples of textual presentation is newspapers, magazines, etc. Now, a serious drawback of this kind of presentation of data is that we will have to go through the entire text to gain a conclusion. Let's say you read this. What's your conclusion? Probably that the entire paragraph will continue talking about artificial intelligence. But now let's read the complete paragraph. Now, actually, this entire paragraph is about humanity's intelligence instead. Now, let's understand the tabular presentation of data. Tables are groups of rows and columns arranged in a systematic order. So anyways, now let's learn about the parts of a table. So now let's discuss the parts of a table. First, there is a table number, which should always be mentioned above the table at the top. And all the tables must be arranged in ascending order according to their table numbers, because these are specific numbers assigned to every table, and they depict the position of these tables in the groups of the tables in which these tables are kept. Well, that's a lot of table calling. Now, below the table number is the title, which explains the content of the table in one or more words. Below that is the headnote, which gives additional information supporting the title. Then after that is the unit of measurement. And remember, the unit of measurement is always positioned to the right of these three things. Now, this tells us whether the content in the table is in weight, length,
or capacity, even money. It also tells if the content is in thousands, hundreds, billions, trillions, that kind of thing. Then there's the subhead, which might seem like a little block, but it isn't little at all. So the subhead over here is the master, or should I say the mistress, whatever you call it, of the entire table. Because it tells the topics of the columns, and it tells the topics of the rows. Get it? So then there's the column heading or captions with subheading, which is the heading or the topic of each of the columns. And just like the column heading, there is the subs or the row heading or sub entries or subtitles of the rows of the tables. You can see each of these are the topics of the rows of the tables, and they're called a variety of names. Then these little blocks which make up the body of the table are called cells or items of the table. Below there's the footnotes, which at last is an additional placeholder, and you can write a little note over here as well, telling a little bit more about the table and making the end perfect. And below that, you can write the source of the table. But if you say the source of the table is my mind, that wouldn't quite fit on a formal table. So we've understood now how, or should I say, what are the parts of a table.
Also, remember that the tables based on classification can either be chronological, spatial, qualitative, or quantitative. Now, tables can be classified based on originality, purpose, or construction. Now, let's first talk about purpose. There are general purpose tables and specific purpose tables. Now, general purpose tables are those tables which are created with no specific purpose in mind. These are also called reference tables. Now special purpose tables are those tables created with a specific purpose in mind. These are also called summary tables. Now let's talk about tables that are classified based on originality. Original tables are those tables where the data is presented in the same way it is collected. But derived tables are those tables where data is presented not in the way it was collected. Okay, now lastly, tables based on construction. Well, this is a little tricky, so you might want to keep your ears open and re-listen this part a couple of times. Now, tables based on construction can either be one-way table or a one-way table or a complex table. Now, a one-way table is where only one attribute of the data is told, but a complex table is divided into three more categories. Double or two-way table, where two attributes are told about the data. Treble or three-way table, where three attributes of the data are told. And lastly is the manifold table, where more than three attributes of the data are told. Now there is the diagrammatic presentation of data. There are three kinds of diagrams in the diagrammatic presentation of data. So there is metric diagrams, frequency diagrams, and arithmetic line graphs, or shall I say, time series graphs. Now, geometric diagrams are divided into bar graphs, which we learn at our young ages, in our favorite chapter, data handling, or pie graphs or pie charts. Now, pie charts also, we've learned it in data handling, so these will be a little easy for us, okay? Now, bar diagrams are where bars or rectangles are leveled into the numerals they stand for. So let's talk about the 5 kinds of bar diagrams. First is a simple bar diagram, which is the normal ones we study in our schools. And now there can either be a horizontal bar diagram or vertical bar diagram, like this and this. Now these bar diagrams, both horizontal and vertical, are types of simple bar diagrams. So much complexity. Okay, now the second one is multiple bar graph. Now remember that multiple bar graphs is not too many bar graphs, okay? Because I'm saying multiple bar and graph is singular. That means there are multiple bars in one graph. And this kind of bar diagram is used for bivariate or multivariate frequency distributions. Then the third is differential or component or subdivided bar diagram. Now in these kind of bar graphs, they are broken into different parts. The bars are broken into different parts, signifying an entire bar and the pieces of the bar. But percentage bar diagram, which is the 4th kind of bar graph, is also having different pieces. So what's the difference? Well, you see, in percentage bar graph, the height of bars is all equal, but their pieces height are different. But the thing is that in differential bar diagrams, the heights of the bars vary, and the numerals the little pieces stand for also vary. So last but not the least is the deviation bar diagram, where both positive and negative integers are included. Observe this. This is a deviation bar diagram. Now let us learn a few ingenious features of this graph. Firstly, the breadth of all the bars is equal and only the length differs. Secondly, most of the bar diagrams are simple and vertical. Thirdly, there is an equal distance between all the bars in the graph. Fourthly, there is a common baseline for all the bars. Fifthly, the bars should be arranged in an ascending or descending order. Sixthly, we can color these bars in whichever colors we like. Now there are pie charts. Of course, we also know all these pie charts. So there are 2 kinds of pie charts: 2D pie charts and 3D pie charts, which are based on their dimensions. Now let's learn how to create a pie chart. So first of all, we'll need to do a little conversion in the values given in the frequency distribution. So first of all, if those values are discrete variables, then what will we do is that we will divide it by the total and multiply it by 100. Then we will place a percentage sign at the end of the product, because then it becomes a percentage. Like this, we will do this with all the discrete variables given. But if they are already percentages, then skip this step. Now, after this, what will we do is that we will multiply each of these percentages by 360, then divide it by 100. and remove the percentage sign. Instead, place a dot at the top right of the new. Now it becomes a degree. But if the values are already degrees, then skip both of these steps and start the steps from on. Now what you'll do is that you will use a protractor and create a circle based on these very degrees as shown.
So now let's create a pie chart. Okay, Mr. Red Dot activates. Now as you can see, the revenue of company ABC across 4 quarters are given. All the 4 quarters are given. So you can see that in the first quarter, the company got $82,000, second quarter $32,000, third quarter $14,000, and fourth quarter $12,000. Then we convert these discrete variables into percentages, as I told before, and then into degrees. Now these degrees are already made. Like I created them, so they are made. Okay, now let's first create the graph, like a square in case you're not using a graph paper. Okay, so we've separated this black part from the normal green part. Okay, now that we've separated this black part from the green part, then we can write the chart title, which is the revenue of company ABC. And then we can write the legend or the key. It's not the legend or the key to a lock. It's actually pretty simple. It denotes which color represents which quarter. Then we draw a circle using a compass, and once we've done that, we can see that we need to create 210.9 degrees for the first quarter. So first, before that, we will create a radius from here to the middle. Okay, right over here. So once we've done this, we will place a protractor's starting point over here and count 210 degrees from this very line. So 210.9 degrees, we're coming right up. And voila! You can see these 210.9 degrees created from this protractor. And if we remove this protractor, we have a beautiful blue baby. No, actually not a baby. So then we can choose either this part or this part as the starting point for our next quarter. So let's say I choose the above radius as my starting point once again. And now I need to create 82.3 degrees. Voila! We have created, is it orange or yellow? I don't know. Okay, so once we've done that, you can see that from here, which is the starting point, to here, which is the ending point, we've created the exact same 82.3 degrees. Now, let's remove this protractor, shall we? They're much better. Okay, now let's again check what's the degree. Now it's 36 degrees. Now over here, you can take this as our starting line again. Now 36 degrees coming right up, voila! From the grayest mountains to the grayest oceans. This is the gray part, which represents the third quarter. And obviously, you can color the rest part, which represents the fourth quarter. There's no need of the protractor now. So, voila, we have the gray part done. And now let's do 30.8 degrees, which is the remaining amount of degrees. And I guess I didn't need the protractor for this one, but I prefer it anyways. So yeah. Wow, this was so beautiful. I mean, this is so beautiful. And wow, we've learned how to create a pie chart. Not a 3D one, because, it's a little difficult to make 3D on a graph paper. So yeah, we've learned how to create a pie chart.
After geometric diagrams, there are frequency diagrams. Now, there are three kinds of frequency diagrams: histogram, polygon, and the ogive. So first, let's talk about the histogram. Histogram is a bar diagram without the spaces. And unlike the bar graph, it is two-dimensional. And you'll say two-dimensional? Then what is a bar graph? Three-dimensional? One-dimensional? Well, actually, I'm talking about this in a different way. Now, we both know that the bar graph can either be 2D or 3D, but I'm not talking about it in that way. Because in a bar diagram, what is actually happening is that the breadth is equal and the length is what that matters. But in histogram, both the breadth and the length matter. That's why a histogram is 2D and a bar graph is 1D. Let's understand that with an example. So let's say that, for example, we have got the marks of a couple of students. Now, if we portray those marks in a bar graph, then it would look like this. Now you can see that it is a little weird portraying a frequency distribution as a bar graph, because you can see the 10 to 20, 20 to 30 written on the x-axis, and that doesn't seem correct. Because technically, most of the times, frequency array is used in a bar diagram. But for a frequency distribution, you use a histogram. For the same marks of those kids, if you create a histogram, it looks like this. It seems more correct because a histogram is made for a frequency distribution. Then there is the polygon. Well, in math, what is a polygon? It is a shape. And in statistics, as a frequency diagram, a polygon can be a regular or an irregular shape. And it can be like this, or any other kind of shape.
Well, how to create a polygon?
Oh, that's pretty simple. First, we draw the histogram with a light pencil and make small or average size but visible dots at the middle
Of the top.
of every bar. Or shall I say every histogramish bar? Okay, then we join those dots and erase the histograms from behind. And voila! You get a polygon. Now there's another way to create a polygon. You can instead take the mid values of each of those classes, and then you will make the dots, not the pot, where the mid values are located, and then join those dots to form a polygon. There is another frequency diagram whose name I didn't mention, which is the frequency curve. Don't know where that came from. Okay, now the frequency curve is just like the frequency polygon, except for instead of those straight lines which we make to connect the dots, it is a curve. Okay, and it can be any kind of curve. Remember that. So there are 8 kinds of frequency curves. First is the normal or symmetrical curve, where there is a straight line through it and there is a symmetry, okay? Because it's told in the name that is a symmetrical curve. Then it is the positive skewed curve, which is skewed to the left. And then there's the negative skewed curve, which is skewed to the right. there is a U-shaped curve where it goes on a high level first, then a low level, and then a high level. Okay, and forms a U. Then after that is the bimodal curve, where there are two maximum or high level points in the graph. Then there is the J-shaped curve, okay, and it's shaped like a J, as you can see. Then there's the reverse J-shaped curve, which is shaped like a mirror image of the J-shaped curve. At last is the multimodal curve, where there are more than 2 points that are on the high levels in the graph. So at last, there is my dear friend, the ogive, which is created from a cumulative frequency distribution. To know more about this frequency distribution jargon, watch my last video based on it. So those who have watched that video must remember Shreya's cumulative frequency distribution. So let us create an ogive from that very cumulative series. Also remember, like the cumulative series, there is the less than and the more than ogive.
So now we can see Shreya's frequency distribution. Red dot activate. Okay, so you can see the marks over here. Less than 10, less than 20, less than 30, less than 100, and so on. And then there's a frequency, which tells how often kids got less than 10 marks, less than 20 marks. And you can see the entire ogive over here. As you can see that the frequency of 8 is displayed here, 9 is also displayed. Then there's 21, which is also displayed. Then there's 26, which again is displayed. You can see like this, there's a less than ogive which continues to rise in such a trend. But it's supposed to be a less than, and what is this all mumbo jumbo? Shouldn't it be going down as it's less than? No. Here we're signifying less than 10, less than 20, less than 30, and so on. So less than 10 signifies all the kids who scored less than 10 marks, and that's 8. So less than 100, which is the total marks, it's actually everybody, the entire population. So we can see how an ogive is formed and how different is a cumulative frequency distribution from other frequency distributions. The ogive, after all, suits these colors, doesn't it? Voila!
So this is the result. We now know how to portray an ogive. So the third one is an arithmetic line graph or time series graph. So first let's learn about both the axes. Now both of these axes, the y-axis and the x-axis, have a positive side and a negative side. So now these two axes divide the entire graph into 4 quadrants. Quadrant 1 has both positive x and positive y, and this is the most commonly used quadrant in the graph. Quadrant 2, on the other hand, has a negative x and a positive y. Then there's the quadrant 3, where there is both the negative x and the negative y. So negative. Okay, and at last there's a quadrant 4, which has the positive x and negative y. So remember that the x-axis is also called the abscissa or the horizontal axis, while the y-axis is also called the vertical axis or the ordinate. Also, as the name suggests, the time series graph suggests that this graph is often used for chronological classification. Now, this is a time series graph. This is an arithmetic line graph. So now, remember that there are a couple of things that are important in a table. In a graph, in these arithmetic line graphs.
So there are a couple of points that we must remember while creating a line graph. There should be a concise and self-explanatory heading. There should be an appropriate scale and size. And the simplicity of the graph should be maximum with the minimum use of words. It should be attractive and effective. The reader should understand the graph just with a glance. There should be different types of lines like colored lines, broken lines, dotted lines. There should be different types of lines for bivariate or multivariate graphs. So there should be the uniform thickness of the line or lines. We should, or you could say we can provide the table of data as well, if it is possible. And then there is the false baseline, which is a cut or kink in the axis. And then you'll think, what is the false baseline? Why do we need it? What is its use? Okay, stop with the questions, start with the answers. Okay, so Shimra, actually, the false baseline is a cut or kink in the axis because the minimum value in the frequency distribution is very much above 0. For example, if you're measuring the tons of wheat, it's an example, okay? This is my imagination, not the true data. So if you're measuring the tons of wheat across entire India, then we can write the provinces of India and the tons of wheat they produce. But the minimum tons of wheat was 900 tons of wheat. So technically, 900 is a lot farther from the graph. But you know what's farther? It's the cost of the Bitcoin. And a couple of the top cryptocurrencies. Okay, that word slipped my mouth. I admit it. So anyways, the top cryptocurrencies start somewhere, let's say, from 10,000 rupees. So technically, you don't think we can start 10,000 rupees like that only. It's a lot far from 0. So for that, we will make a cut or kink between 10,000 rupees and 0 in the axis. And that will signify that, yep, there is a lot of big differences between this 10,000 and the 0. So that's it. These are the points that we need to remember while making a line graph. Thank you.
So that's the presentation of data explained. Are you satisfied? Very. You bet. So remember that the greatest are not those who never fall, but the ones who dust themselves and get up once they fall. Thank you for tuning into my channel, and don't forget to like this video, subscribe my channel, and share this video and this channel to your friends and your family, as these are the things that make me get up and start making these videos for you. So today's question is that what are the 2 ways through which a person can create a frequency polygon? Thanks once again, and don't forget to hit the notification bell, as I'll tell the answer in the next video. Me, okay? Not you.